If you're here, you probably came from James Allcott's video about the Euro simulations, and you're wanting a bit more of an in-depth view on how the simulations are actually created. Well, my name's Craig, and I'm here to do just that, and I'm going to do that over this lovely PowerPoint which I've created, and I will show you now. So in order to generate the simulations for the Euro 2024 tournament, we'll be using something called a neural network, which is a type of machine learning. So these networks are really good at identifying patterns and trends in input and output data, and we'll use this to predict individual matches, which will then in turn allow us to simulate the full Euro 2024 simulation. So a neural network is this complex AI tool, but really we can just imagine it as this box. And at the moment, this box is empty, lacking any data. So to give it knowledge, we'll have to fill up this data with over 1,800 games of competitive games between European nations spanning back to about 2003. For each game, we'll provide a bunch of stats. We'll give it the home team's form with past 5, 10 and 20 games, which is weighted towards who they are playing. We'll give it the current world rankings. We'll give it the performance of the most recent Euros, performance of the most recent World Cup, and the points per game, goals conceded per game, and the goal scored per game in the most recent Euro qualifying. And the important thing is, we're not putting it in for these teams now, we're putting it in for when these games happen. So for example, in an England and Croatia game in 2008, for example, we'll take the form and the world ranking and the performance of the most recent Euro qualifying at that time the game was played. And what we'll do is we'll take the stats for both the home and away team, and we'll put these into the model as well as the actual output result. And what we'll do is, as we put more and more games in, the neural network will start to train and will start to learn the patterns and trends between these input stats and what the final result turned out being. Once a model is fully trained, we can now use it to predict future games as long as we input the same stats. So, going to the Scotland-Germany game, which is the first game of the Euros, if we put in the stats of Germany and Scotland, which are currently happening, we can get an output prediction result. However, this result isn't something like a 1-0 or a 2-2, it'll be a bit more complex. Instead, it's a percentage probability for each team to score a certain number of goals, based off what the model has learned through the training data. To convert these probabilities into actual results, we'll place them on a scale from 0 to 100, and we'll take a random point along that scale, where wherever it lands, that's the number of goals that team has scored. This allows over 10,000 simulations, you can have unexpected results. You'll have the 4-4s, you'll have 4-0s now and then. Just like you would in real life, there is a chance that can happen. However, as we're doing 10,000 simulations, the most common results will prevail, based on the probabilities that the model has given for each team. So now, we can simulate the full Euros by just going game by game, passing it through the model, getting an output prediction as we go through the group stages, and then going through the correct knockout ties based off the group stage results until we have our final winner. And as we have this random probability which is weighted based on the model, no two simulations will be the same. However, again, as we're doing 10,000 simulations, we'll end up getting a fair representation on what the model has predicted. So I've now got a few extra points just to which go over some finer details within the model. So the first one, as you might suspect, as we're training on home and away games, we're using qualifying games, we're using Nations League games, the home team will be biased in those games, just like in real life, which means when we're using it to predict future games, there will be a bias to whoever we deem the home team. To get over this, we put each game in the model twice, one where each team is the home game, and then we take the average probabilities from both of those results to get our final probabilities. The only exception to this is Germany, as of course they're hosting the tournament where they actually are the home team. So whichever game they play, they are the home team. Secondly, in the knockouts, when we have a draw, all we do is we just basically do a flip of a coin, a 50-50 chance, because that's really how I deem penalties. I mean, of course, we could do finer penalty searches based off team's history, but we're just going to do a flip of a coin. Another question people might have is, when we put in a team like Germany, who haven't had any Euro qualifying games, how do we choose? Well, we just use the previous qualifying cycle, which isn't ideal, but it should still work, as the teams haven't changed too much in the 4 years. And this also applies to in the training data, so when we're training on, say, Austria and Switzerland, when they were hosting the Euros, we'll do the same. We'll take their Euro qualifying stats from the previous cycle. And finally, if people are wondering how we've defined performance at World Cup and Euros, we've just done this numerically. So if a team didn't make the tournament, they've got 0 points. They made the group stage, they've got 0.2 or 0.3 depending on the tournament, and so on. So now I hope you have a better understanding of how the model works and the input stats that go into the model that choose how strong a team is. If you have any other questions, feel free to comment. Of course, there's much more final details that I haven't discussed in this video, and yeah, cheers.